for the Miracle flagship project at the University of Basel, we developed this virtual reality room. What is unique about this virtual reality room is that for the first time we provide volume rendered images in real time, which allows surgeons and radiologists to visualize their medical image data sets using volume rendering. Then they can walk around, they can grab the object, reposition it, they can also change the size, zoom in or zoom out, rotate it at will, so that they have the most comfortable and best view of the scene. As an additional option, we also gave them a cutting plane. This cutting plane can be used to either cut through the volumetric data set, to, for example, cut open the skull or the rib cage for a better view of the scene behind it. But at the same time, I can also switch this cutting plane into the CT mode. So I have a plane which can be freely moved around and visualizes the CT, the original CT data set behind the scene. And this virtual reality room provides a very intuitive way of positioning these cutting planes in 3D space. During the project, we realized that the shadows cast by the objects are quite crucial for an increased depth perception. In order to emphasize this, we also integrated an OR lamp into the scene. This OR lamp can now be switched on, and we can freely select the brightness of this OR lamp. And if we move around this OR lamp, we can see that the shadows cast by, for example, the rib cage continuously change with the motion of the OR lamp. And exactly these shadows are quite crucial for an increased depth perception. This virtual reality room, developed as part of the Werner Siemens Foundation funded Miracle project, was only made possible with the recent development of virtual reality glasses, as well as GPU graphics hardware, of course combined with our quite unique volume rendering framework.
Digitalization is one of the most important driving forces for technological trends and new developments. The networking of machines and systems, as well as gathering information on basic and status data of devices, forms the basis for that. The added value this data provides is demonstrated in Phoenix Contact's in-house tool shop. Thanks to the comprehensive networking of all machines and tools in production, setup times of injection molding systems can be reduced significantly. Every workspace offers access to tool data and databases with animations and 3D models on every tool. In addition, toolmakers can also use augmented reality systems that facilitate processes and reduce the error rate. That's how the complex injection molding tools can be classified immediately. Sprue runners, heating and cooling circuits, as well as the optimum tool temperature are indicated, precisely where they are located. The facility management in Bad Pyrmont also uses AR technology today. The required data is provided by Analytics, the Phoenix Contact building management system. Thanks to the intelligent networking of the entire building technology, every user has access to the right information at the right time. External maintenance personnel is led independently and informed about everything that is important in the event of a maintenance work. Controlled safety instructions are given directly on the spot, immediately before use. With the high level of data depth, Analytics creates transparency. Augmented reality technology makes it possible to experience this transparency.